Hello. So today we are going to look at Fibonacci numbers. So let's start. So again, as usual, hash include stdio.h standard input output, and I'm going to write the main function. And so Fibonacci numbers, we're going to have a function Fibonacci, and okay. So Fibonacci, it's going to take an integer n, and it's going to return the nth Fibonacci number. Okay. Function returns the okay. Yeah, and so what's the base case? The base case is basically the first and second numbers. We know if n is equal to 1, so it's return 1, right? And I can add the or condition here and say that if n is equal to 1 or n is equal to 2. So if n is equal to 1 or equal to 2, you return 1, right? The first and second numbers are 1. So first and second Fibonacci numbers are 1, and then the nth Fibonacci number is basically return the n minus 1 plus n minus 2. Right, so this is a very succinct shorthand notation. If I had to write this thing properly, I would have written it as int x equal to Fibonacci n minus 1, int y is equal to Fibonacci n minus 2, and then I would have written x plus y. That would be a long way to write this thing. So what I have written here is a very succinct notation. That's it. Okay. So this should give me the nth Fibonacci number. That's the main idea, and we can test this here. Int n is equal to, let's say, 5, and printf percentage %b yeah, so that's it. So I mean, I just printed that the nth Fibonacci number is d. Okay, now let's compile gcc fibonacci.cc, oh sorry, .cc. There's something wrong. There's some, okay, so it's a syntax mistake. There's no Fibonacci. It's done. Now I come run. So the fifth Fibonacci number is 5. Yeah, and we know that's right. So what about the first? I had to compile it, right? First is 1. What about the 10th? So the 10th is 55. Okay, so we know how to print the nth Fibonacci number. Okay, so that's good. Now going to the next function, next program. That's something we were telling how to I give you a set of numbers, let's say 1 2 3 4 5. I want to print all its subsets. Okay, print all the subsets of these numbers 1 to n. That's the next program we'll be interested in. So let me take a new file and let me save it as what is the file name? Subsets.cc, and I'm going to start hash include .h menu. Okay. Right. So first let me take an array, int array of integers, right? And I want some array size, int const int ar size is equal to, let's say, 5. Then ar size is equal to, okay, so what I have done is I have defined an array of size 5. That size 5 is now fixed as a constant, and then I have basically I have assigned the first the 5 elements are now going to be 1 2 3 4 5 in the array. Right, now I want to print all its subsets, so I'll have to have a function basically print subsets, or just subsets, okay, subsets, and I'll pass in the array, okay, and I also should pass in the size of the array, right? Maybe I have to pass in the size of the array. I pass in the size of the array because I need to, like, the function won't know how big the array is, right? There's no other way. In C, there's no other way. There's no way a function can find out what is the size of the array. So we need to explicitly pass the size of the array, and that's what we have done here. Now I'm going to have this function. There's no return here because I just want to because we are interested only in printing all the subsets of that set. Okay, now what was the logic we were telling? So we want those who had missed this thing, so I am talking about you can watch the theory lecture where I tried to explain the logic behind this, the idea on how to print all subsets. So we described the logic there. I can briefly tell here. The logic is basically that I am going to pick the first element. Okay, so let's say I'm going to store, I'm going to take x basically, which is AR of 0. Okay, I just picked the first element, right now 1, and then I'm going to consider all subsets of 2 3 4 5, and then basically I partitioned my I'm going to have two recursive calls. In the first recursive call, I'm going to assume the first number 1 is not going to be there, and I'm going to print all subset of 2 3 4 5, all subsets which occur with 2 3 4 5. That's what I will print. And the second recursive call, what I will do is I will print all subsets which contain 1. Okay, so every subset in the second recursive call which will be printed will contain 1. So that's how I'm going to arrange it. So that will be 2 recursive calls. Now to do that, yeah, so I have to call okay, so so we'll try to call it recursively, and then while we try to build this thing, we'll realize that we'll have to have more parameters into this set, into this function. The function should take more parameters, and that's something you'll realize here, because that's required in the recursive steps. You'll have to give more parameters for the sets. Okay, to the function. The function will take more parameters in the recursive step, and that's something we'll have to take care of. Okay, so that this is a standard thing in so this is a recursive algorithm, and this recursion is very similar to what you will see in your discrete math course as mathematical induction. And again, there you will see that the inductive hypothesis, basically the recursive step here, you will have to sometimes you will have to change the inductive hypothesis, make a stronger inductive hypothesis for things to work better. to get your proof working. That's exactly the same. Okay. That's the same idea being used here, that you need to have uh, a stronger function here, a function which takes in more parameters. Okay, so yeah, so that's going to come soon. So that's a warning. So you can just keep it in your back of your head. What is it we are interested in? Yeah, so what is the main idea? See, if I take this first element 0 here, right? I pick the first element 0, and then I need to see, when I'm going to call it recursively, I want to consider this array only from array index 1 to AR size. That's all I want to call, right? Because I want to exclude 0. Now how do I tell it to the subsets? So if I have to tell it to the subsets, to that function, I need to pass in that bit of information, that you should not be considering the first index, right? So that's the idea. And so right now you take the first set, and recursively when you do, in the next level of the recursion, it's the first and second which is going to be avoided, right? Okay, so 1 and 2 will be avoided, right? And then you are going to consider only the array size, array from 3, 4, 5. So in that recursive step, you will have to again say that, okay, in the array AR, you will have to exclude the first 2. So that information should be recursively sent, and therefore we'll have to consider one more parameter. Let me call it int basically the array beginning, right? Where does the array begin? Okay, so that's the kind of information. So where does array begin here? I have to pass in 0 because it starts at 0. Okay, now okay, so this is clear. You'll soon see we'll have to pass one more thing, and this much is clear. Now how do I recurse? What is the, yeah, so I took int x equal to AR0, and then I'll have to basically recurse from int basically I have to pass in AR, and I have to pass AR size, which does not never change, but I have to pass the beginning has now increased by 1, right? And this is not AR0 because so first time you call it's AR0, but next time it is AR begin, right? The first element in the beginning of the array. So recursively, that's what you are capturing. Initially it is 0, and the next round you go, it becomes 1. So that's about the element 2. Okay. Right. Now comes the next one more. Now, okay, when is this going to be printed? When do you want the array to be printed? Okay. So the main thing is that the array this one subset. When do you want the subset the one subset to be printed? So we will print the subset in the base case when you reach a situation where there is no more element in the array, right? For every array element, I have decided whether to include it or exclude it. When I reach that situation, I am going to print that. So that's the base case. And when does the base case happen here? We can just check. When does the base case happen? The base case happen when, yeah, so think about it. If the array size is 1, array has just one element. Is that the base case? Okay, or let's say the array has no elements, right? When the array has no element, no more elements, that is, we have basically AR beginning has basically covered all the elements. And when will that happen? So AR beginning, then in that case AR beginning will be equal to AR size, right? So think about the following the situation. Let's say the array has one element. what happens? It comes here. So AR size is 1 and AR begin is 1. It comes here, it goes to the next thing, and AR begin becomes 1. And now you know that already we have decided on the first element, right? And so we are in a scenario where we have reached the base case. Okay, so AR beginning is equal to AR size. Now in this case we have to print, but what do we print? We said that we have decided for every element, we have decided whether it has to be included or not, right? So that information also we have to pass. Only then I can print that fact, whether every element is included or not. So I will have to print that. So now to for that, then I will have to basically include that information also. So I am going to carry one more array here which carries that information. Int info. Okay, so that's going to carry the information that whether the array element should be included or not. And initially we'll just have AR. So okay, I have to create the array and then I just pass. Okay, now I can print that. So okay, so let's assume I have that array. How do I now then tell whether should I include or not? Okay, so that's easy. What I'm going to say is that I'm going to have int of AR beg is going to be 0 if I don't want to include, and then I will call this like this, and then I'm going to call it again and say that array element should be included. Okay, that's the next thing. Okay, so basically I can remove this. Okay, now I can print. What am I going to print? Let me write a new function to print that. Print subset. So I'm going to print it here. So I'm going to first have this. Let me have start a new line. Then I will write for I equal to 0, I less than AR size. So printf %d okay, but I don't want to print this always. I print it only if info of that index is true, is 1. Okay, only then I need to print this. It's clear? Okay. Yeah. So we can put us and if you want it in a yeah, it's fine, right? Okay, and so now if the AR size is equal to the base case, then I just call this function AR comma info comma AR size, and this is going to be my base case, and these are my inductive steps. Okay, so the program is very short, but it's a little complicated, so let me just run and see. So it's gcc subsets.cc. Yeah, so many errors. What is I? They are asking what is I. I didn't define that, so I'm going to define that here. Yeah, that's it. Done. Okay. So this is something you are going to see. It's a segmentation fault. This is an error you will see, and it means basically that I am accessing an array at some location where I should not have accessed. As simple as that. Okay, where am I accessing it? Let's try to find that out. Okay. Okay. Do you know what happened? Yeah, I didn't do anything after the base case, right? So what is the base? I mean, I have to return after that. Right, if I don't return after printing, it's going into the next line, and it's going into the next line, and then yeah, it's going. I mean, the function never stops. That's the main point which we are trying to make, that the base case is the last point, and then you just keep on going. You return back. Now you should see something, right? Okay. So all subsets, maybe we'll just make it 3 to see how it works. And is 3 good? 2 is better. First let's add for 2, and then we can see. Okay, I'm going to add one more printf here. Or wait, I'll do the following. Okay. One more thing I need to print. If there is no element, I have to print its empty set. I didn't do that here. So how do I? Okay, see, that's the first. Do you know why there is a gap here? Because it's empty. It's the empty set. It comes here and then it prints nothing. Okay, so if I want to print the empty set, I need to keep track of the fact that is there like info of I is equal to 0 for all everyone, right? I need to keep track of that fact. So what do? I just have something bool underscore empty. Okay, so it's initially it's set to empty, and then I'm going to set it to not empty if okay, and then I'm going to add here empty if this is the correct notion. Okay. Okay, because when it's bool is not empty, bool empty not empty is equal to 1 means bool is not empty, right? So that's why I have this. Okay, then you print empty in that case. So let's do that. Yeah. So initially it's empty, then it prints 2, 1, 1, 2, right? That's the 2 sets. Okay, how does this work? Right? How is it working? Do you want to look at that? Then we need to print. What do we print at every stage? So do one thing. At every stage of the recursion, I'll print the AR beginning and AR size. Okay. And I will also print whether you need to include one element or not. Okay. Yeah. So let's have that. Let's just try to print. So I'm going to print it here. Okay, and also I'll print recursive call. Okay. Okay, so now let's see. So initially when the function is called, from here AR beginning is equal to 0 and we are here, right? And then we come here and this is first element 1 is not included, so that we have that 1 is not included. And then because we set it to 0 and then we recursively call that thing. We call the function from 2. We come here, right? And so AR beginning is now 1, so set only 2 is going to be considered, and we come here and no, this is not included. This is not called because AR size is 2, right? And it comes here and it's going to not include 2. Okay, so that's 2 not included here. And then it comes here again, it calls this function again. Okay, and it goes there and it comes there and realizes it comes here and AR beginning, because it's 2, right? AR beginning is 2, and so that both are same. AR beginning is equal to AR size. Therefore you go and print subsets. When you go print subset, you come here and because everything is, as you could notice, both 1 and 2 are not included, and therefore it's going to be an empty set, and therefore in the recursive set call here you get empty. Okay, right, you get empty there and you come down. Okay, and this print of, I will just put it on top. Makes sense. Yeah, sorry, that's the better way to see you. I find it not comfortable. Okay, now so we have AR, so it's empty, right? So that we saw, and then so let's go through it again. Okay, initially AR beginning is 0. We come here, AR recursive call AR beginning is equal to 0. 1 not included. That's because it comes here and it comes here. 1 not included. And then it calls the next thing, right? With AR beginning is equal to 1. It was 0 in the beginning, it goes there. So now we are going to consider only the array from index 1. So there is only index 1 because only 2 elements. So it comes here, and then again AR beginning is not equal to AR size because AR size is 2. It comes here, again 2 is not included because 2 is the next element. It comes here, so that's what recursive call, this thing 2 is not included, and then another recursive call with AR beginning set to 2. It comes here, AR beginning is 2, AR size is 2. It comes here, print subset, and it comes here. Now both 1 and 2 are not included here, and therefore it's going to print empty. Good. Now what happened? It returns, and where does it return? It returns to the previous case with 2 not included, right? and it's now going to print, it's coming down and going to print 2 included, right? And then the recursive step with AR beginning 2 goes there, again print subset goes there, because AR beginning and AR size are the same, it goes here. So 2 is included, so it has to print 2, and it prints 2 here, right? Yeah. And returns, comes back here, it's a return here now that is returned to the previous case here with 1 not included case, and then it comes here and prints 1 included, right? So 1 included comes, so this is 1 included, and it goes to the next thing with AR begin 1, right? And it comes down again and sees not included for 2, right? Because the index is at 1, so now 2 is not going to be included, and it comes here, goes again, comes here, and then AR beginning and AR size are same, because it's of size 2, goes there, it prints 1, right? And then returns from this and comes here for the 2 not included case, and then comes down and 2 included. Once 2 is included, it's going to call this recursive function again, then it goes here with AR beginning and AR size both 2, and then it goes to the print, comes here, and 1 and 2 both will included, and then return, and then everything gets returned. Okay, it's a little tricky to understand, and this return is not really necessary. That's just for us to understand. It's a little tricky to understand. So the best way to understand this thing, you need to work out, and you need to program this and see why this is working. Just like we did last time, do the indentation and like the block way to see the execution path. Try that and see, clearly understand how all this recursion is happening, and because that's going to help you in solving this thing. Now, since if you had liked this, see, here is another problem which you can try this thing out, then try to do something on your own. So here is something you can try to do on your own. Print all subsets of size k, right? So let's say print all subsets. So your array can be big, 10 elements, but you want to print only all subsets of size 5. Okay. So that's another thing you can do. Print all subsets of size 5. Okay. So here we are going to print all subsets. There, print all subsets of size 5. That's another question you can try. Then you can try to do the similar thing for printing all permutations. Okay, of the this set of numbers are there, 1 2 3 4 5 here, and then you want to print all permutations possible with those 5 elements. That's also so that's also you can try to do, and that's what I'm going to give that to you as an assignment problem. That will be your next assignment, to print all permutations of the given set, right? Okay, so so while you are going to program, the main thing you are going to get as an error is segmentation fault, core dumped. These are the kind of errors you are going to see, because somewhere you are going to access an array out of its bound, so you'll have to be careful. That's something you need to work on. Okay, that's it. Thank you.